Hello, my name is Miss Townsend, and I rather fancy mathematics. Welcome to Maths with Townsend. This video is for students in the 10th level who are studying quadratic relations. It's about word problems, those nasty word problems, the ones that come with no equation, and therefore you have to create an equation. I've handed out a worksheet to you on it, and this is question number 12 from that worksheet. Let's have a look at the question then, shall we? Here it is. It says a sporting goods store sells 90 ski jackets in a season for $200 a pop. Ah, that's quite a price. Each $10 decrease in price would result in 5 more jackets being sold. Right, $10, that's a good bit of quid. Huh. What price should the store sell in order to maximize their revenue from ski jackets? We haven't done a lot of problems like this. Let's see what we can do. We're going to start with a price. So again, I'm thinking. So originally, the price is going to be $90, 90 quid. And we're going to sell. No, wait, I got that backwards. Sorry. Originally, the price is $200, 200 quid. And we're going to sell 90 jackets. Am I becoming Australian? Pay attention. You never know where this accent's going to go. So, originally, we have a price of $200, and we're going to sell them for 9. We're going to sell 90. So our original revenue, we can calculate. Revenue 200 times 90. So originally we're making 18 grand off of those jackets. That's not bad now, is it? However, we're being greedy. We want to maximize our revenue, don't we? So we're going to decrease the price and see what happens. Try to sell more by decreasing our price. Now, we know that for every $10 decrease, we get 5 more jackets sold. The question is, how many times should we lower the price by $10? And that's why we're going to introduce X. X is going to be the number of $10 price decreases, right? So a little confusing here because it's not the amount that I decrease, but rather it's the number of times I decrease by $10. And that's important because we know that for every $10 decrease, 5 jackets are sold. So we can't break the $10 up because we only know what happens with $10 decreases. So if I were to formally solve this, my accent's just getting cruddier and cruddier. Should I drop it? What the heck. Right, here we go. We're gonna let X represent the number of $10 price reductions. Oh, good word, thank you. So X is going to represent the number of $10 price reductions. Oh, look, I'm already no accent. That's fine. It was distracting anyway, right? Because it was so perfect. Let X represent the number of $10 price reductions. Therefore, the new price of our ski jackets is right here. It was originally $2, but we're decreasing the price $10 for every X. Does that make sense? Good. And the new number of jackets sold were originally I sold 90. But for every X, I'm going to sell 5 more. So I'm going to sell this many jackets at this price. So therefore, what's my revenue? My revenue is selling price times number sold. And there's my equation. And I want to, I want to maximize this equation. And that means I want the vertex. So here's an equation. It's quadratic because if I were to multiply everything together, I would have at one point 50x squared. But I'm not going to multiply everything together because if I want the vertex, I don't have to use a quadratic formula. I could try factoring and get my roots that way. So I'm going to let r equal 0, and I'm going to find roots. And again, it's already factored for me. So I'm actually taking kind of the easy route because I'm solving by factoring, and I don't even have to factor. It's already done. So I have 2 things multiplied together, and they equal 0. So if this bracket is 0, I don't care what's in this bracket, I have a true statement. Equally, if this bracket is 0, I don't care what's over here, I have a true statement. So I need to figure out what value of x makes each bracket 0. So what makes the first bracket 0? Go ahead and solve like it's grade 9. The value of 20 makes the first bracket 0. And what makes the second bracket 0? So again, set it equal to 0, solve for x, and I get a value of, oops, this was a plus sign, so that's a minus sign. So I get a value of negative 18. So now I have the roots. So the roots represent not very good profit. So here's negative 18. That's bad. I have 0 revenue. Here's a root of 20. It's bad. I have 0 revenue. But exactly halfway between them will be my axis of symmetry and therefore my vertex. So let's find where halfway between them is. So the axis of symmetry is at x equals, let's find the midpoint by adding them together and dividing by 2. So I added a negative. So x equals 1 is where my vertex lies. So my vertex is at 1 comma something. And therefore, what is my maximum revenue? So again, here's my revenue equation. 200 plus 10x and 90 minus 5x. And now that we know that x is 1, 210 times 85. So I have a maximum revenue of, if there was a drum roll effect, I would use it. Do, 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 boom, boom, boom. Whoa, $17,850. So let's make sure we've answered the question entirely. Oops, wrong. Let's go back here. What price should the store sell in order to maximize the revenue? Well, I didn't even have to do this calculation I did. It never asked for maximum revenue. I calculated it. But the question is, what price should they sell for? Well, here's the price equation. Remember, x is 1, so the price is $210. Therefore, if they sell at $210, they will maximize revenue. So there you go. I hope that was helpful. I apologize for my accent earlier, but sometimes you get a little punchy doing lots of these videos in a row. And sometimes I like to see if anyone actually watches the videos. Interesting. Anyway, I hope this is helpful. Study for the test, be good people, all that stuff. See you later. Bye.